One is we should provide all the dimensional detail which is required to produce the component. So you need not to know that how we are going to produce the component. It might have been taught in the workshop subject, but here you will be showing the dimensional detail as you know that this is complete one. So one more thing, that you should not provide the dimensional detail again and again. Means if we have different views of any object, means for same object we can draw 3 views. So in some views same dimension is appearing, so it does not mean that you have to show the same dimension in different views. You have to show the dimension in a view where it is uh, having the clear view, and other you should not provide the same thing in different view. So repeat, it is called as repeated dimensioning should be avoided. And one more thing, there are two types of systems. One is the unidirectional system of placing the dimension, and other is the aligned system of the placing the dimensions. So here in this case, the figure which we are seeing, this is case of the aligned system. We will learn aligned system and the unidirectional system. Here one dimensional detail you can see. If a object is broken like this, means object is quite long, which cannot be accommodated onto the paper, drawing sheet. So we can make it like this, that is, it is broken. So dimension line should not be broken. Dimension line should be shown complete one, and the dimensional detail should be put as the actual dimension. So regarding the dimensioning, there are two systems of placing the dimensions. One is unidirectional system, other is aligned system. So unidirectional system, in this you can see there are two figures. One is corresponding to unidirectional system, other is corresponding to aligned system. In unidirectional system, you can observe that if this is the figure or a view or outline of the object which has been drawn. So here in this case, we place the dimension like this, that we break the dimension line in the middle and place the value like this, and it is read, the value should be placed in such a way that it is read from left to right. Similarly, for vertical dimension, we will break the dimension line in the middle and then place the value, dimension value, in such a way that it can be read from left to right. And in third case, where inclined dimension is there, here also we will place the dimension in the middle of the dimension line by breaking it, and putting the dimensional detail, dimension numeral, such a way that it should be read from left to right. So one thing, it in all three dimensions, means length, height, and inclined dimension, one thing is common in all three cases. One thing is that it is kept in the middle of the dimension line. Other is that in all the cases it is placed in such a way that we can read the dimension value from left to right. Like 18 is written is here such a way that we can read it from left to right. But in case of the aligned system, you can observe we haven't broken the dimension line. Although we have placed the dimension value, a dimension numeral in the middle, but we haven't broken the dimension line. So one difference from the unidirectional align system is having that we don't break the dimension line in this case, in case of align system. And other thing is also that there is a, if we place the dimensional value or dimension numeral on the dimension line, it should be read in different ways. Like on horizontal line, it should be read from left to right. For vertical dimension line, it should be read from bottom to top, like this. If we want to read it from the, like if we write it 9, here dimension is 9. So if we read it from left to bottom to top, we will be reading it 9. But if it is uh, read from the top to bottom, it will be looking like 6. So there is only one way of reading it and writing it like that. So we will place the dimension numeral so that it can be read from bottom to top, and read all the dimensions like that. So here also the dimension value is placed in an inclined dimension line in such a way that it should be perpendicular to the, means dimension numeral should be perpendicular to the dimension line. So all three dimensions in this case of line system, you can see they are read from either for horizontal case it is left to right, and for vertical case it is from the bottom to top, and for inclined case it is also from left to right. So these are the ways of placing the dimensions, means unidirectional system and align system. Align system is recommended for your use. So unidirectional system is used for big drawings, and but align system can be used for small drawings also. So regarding the dimensional detail, we have gone through little bit. We will complete the dimensioning later on. But what I wanted to cover, that is the projection of points in today's class that I am going to start.
Sir,
Uh-huh.
sir, can you show the PPT, sir?
Yes. Yes.
Sir, in that align system.
Align system. Yes.
Sir, you told something about 6, sir. What is that? In the
Okay, yes. Means if we place at this place as 6 or 9, like this. If we place this as 6, if you want to read it from bottom, we will read it as 6. But if we read it from the top, we will read it 9. So we don't want to get confused that from where we should read. We should always read from bottom to top, so that such type of confusion can be avoided. And the in the align system, so placing of the dimension is also such that we write the vertical dimension, which can be read from the bottom to top.
okay, sir. Understood.
So projection of points in this, in fact, these projection of points and projection of lines are basics of the projection. Means they are different entities, like from the point we can make the lines. Infinite number of points can make a line. So first of all, we will go through the projection of points, then projection of lines. So here we will start going are going through the projection of points. So here there are three things which are shown here. One is the observer, other is rays of sight, and third is the projection plane. There are three things, and one thing you can observe in this: range of sight is perpendicular to the projection plane, and due to this relationship between the range of sight and projection plane, as it is falling range of sight is incidenting or is striking at the uh, projection plane at 90 degree. So it is called as orthographic projection. What your projection will get from on the projection plane using this way, that is rays of sight are falling onto the projection plane at 90 degree. It is called as orthographic projection. Ortho means perpendicular to. So here in this figure you can see observer is here, range of sight is here, and there is a point situated here at this location. And when observer view this point and its projection, observer can see onto the this projection plane as a point here. So this is the just in introduction of this projection of point. And after that we will see a point situated in the different quadrants. So we can see there is a point A which is situated in first quadrant, and if we want to view it from the top like this, the range of sight is here and the range of sight is here from the right side. So from the top and from the right side, if we view from this point, we will have projection of point capital A onto the vertical plane. This is the vertical plane, and it will be A dash. So on vertical plane, what your projection we will write as a dash, means with a small letter with a dash. And on horizontal plane, projection of point capital A is small a. Small a only will be there. Small letter, what your point is there. So after the small of that, we will put. So in case of the projection of point A onto the horizontal plane, it shows the distance from the line XY. And this line XY, which line is this? Line XY is the intersection of two planes, means at the intersection of two planes, vertical plane and the horizontal plane. So it is distance is shown on horizontal plane and height is shown on vertical plane. So in this case, this a dash is called as, means what your projection will get onto the vertical plane is called as front view, and what your projection onto horizontal plane will call as top view, because we view from the top, we will get it top view and its top view. And when we view from the right onto the projection of that we'll get onto vertical plane, we call it as a front view. So next what we will do, we don't want such a three-dimensional picture of this projection. we want such a projection which can be easily be an easily understandable. And for that, what we do, we show this dimension, these projections, that is front, top view and front view of any point on a single plane. So how we will show it on single plane? We rotate the horizontal plane all the time in clockwise direction by 90 degree. So here you can see the direction of the rotation. So we rotate this horizontal plane in such a way so that we can get vertical plane and horizontal plane in a single plane. So now you can see this in the rotated position. Here you can see this is A dash, which is front view. A is the top view, and this distance, this dimension is showing the distance, and this dimension is showing the height. So, and this is the vertical plane. This is horizontal plane. So, in class, in the practical class, you don't have to show this three-dimensional picture. You just have to point, detail of point will be given, details of the point will be given, and you have to show the projection like this. So this is case when point is situated in first quadrant. Let us see the point when it is situated in second quadrant.
Sir,
This is
sir, in that before one and the two-dimensional part, where is our actual point? That capital A.
here in this case capital A is not shown. Yes, location you can know. Location you can know. Location means distance from the vertical plane of that original point is D, and height of that particular point is H. So that you can see in this. But here, because here in this case we are drawing the projection only, so actual point you can see only in the three-dimensional picture. And here in this case you can get only dimensional detail where point is lying, means we can say that point is projected such a way that its height is h, and distance from the vertical plane is, it is d.
Okay, sir.
So second case where the point is situated in second quadrant, that is point capital B. So if we want to see, viewing direction will be same all the time. Like from the top we'll see its projection onto the horizontal plane, and it will be the top view. And from the right side we'll see the projection of the point, which will be the projection onto vertical plane, and it will be the front view. What we will do in this case, we will again rotate the horizontal plane only in clockwise direction by 90 degree. So what happens in this case, both the planes will overlap each other. So in this case, if we have the height and distance same, then both the projections will be coming at single point. Here in this case distance is more than the height, so we can see it in this way. So distance, that is distance of the point B, capital B, is shown with the help of this projection, that is a projection onto the horizontal plane, and projection onto the vertical plane is shown by B dash. So you can see the both the this is called as projection line. Projection line is overlapping. In previous case, two different projection lines are there, OA and OA dash. So, and in this case both the projection lines are overlapping, means OB dash and OB. So here also we say that FV, that is front view, is B dash, and top view is B. Third case where we can assume that point is situated in third quadrant. In this case, if we view from the top, if plane is opaque, we cannot see the point. And here also, from the right side, if we want to see the projection of point, we cannot see from this side, because we are considering the planes as opaque. But when we consider the planes to be transparent, then we can see the point. So it is assumed in this case that planes are transparent. So we can see the point C, and its projection onto horizontal plane can be obtained as small c, and the distance can be marked, and the projection of point capital C onto the vertical plane can be taken as c dash, and the height of that this point can be shown. So here also we will rotate the horizontal plane only in clockwise direction, and we can make the projections onto the single plane, on 2D single plane, like this. Here C is the projection of point capital C onto the horizontal plane, and small c dash is the projection of the same point onto the vertical plane. And the views you can directly, one thing you can note, in all the cases the projection of point onto the vertical plane will be the front view, and on horizontal plane it will be the top view. There is another case which is the point is situated in fourth quadrant, and you can see in the fourth quadrant also, like in case of second quadrant, we will have the projections like this. Projection on horizontal plane will be E, and projection on vertical plane will be E dash. And when we rotate the horizontal plane in clockwise direction by 90 degree, we will get the planes to be overlapped. So we will have this type of projection. Only projections will be shown below the reference line, that is xy line, and here height, that is for the front view, and distance for the top view can be shown as you can see. E dash is the front view, and E is the top view. There can be another case where the point is situated onto the plane itself. Like here, this horizontal plane is there. Point is situated onto the horizontal plane only. So if we want to get the projection of this point onto horizontal plane, that is small f, we will get at the same location, and we want to get the projection of this point onto the vertical plane, that will be f dash, and that will come onto the reference line only. So here in this case, when we rotate the horizontal plane, we can get the projections. Here f is the projection of that point, which is top view, and f dash is the projection which is lying on the reference line, is a front view. Similarly, we can take another point when the point is situated onto the vertical plane. Here, capital G should be there. So we can capital G should be there. So here capital G should be there. So capital G is the point, and G dash is the projection of point onto the vertical plane, and small g is the projection of point onto the horizontal plane. And this is the projection on horizontal plane is coming on to the reference line. So here also, when we rotate the horizontal plane in clockwise direction, we will get both the projections onto a single plane. So here G is the projection of the point on the horizontal plane that comes onto the reference line, and the C dash is the projection of the point which comes onto the vertical plane. So in this way we have got different types of we have gone through the different types of uh, points. There is another point when we consider it onto the reference line or at the intersection of two planes. So if we get such case, we will have the projection of the point on the reference only. Either it is front view or it is top view. Both the projections will be on the reference line only. So that can be shown here.
Sir,
So if
in this case, in this particular case, what is the use of projection, sir, if all the three are coinciding
no,
on the
it is
reference line?
yes, it is in case of projection of lines, you will find that if a line is lying onto the reference line, then its projection will be onto the to onto the reference line only. It's a practical utility. I cannot tell. Uh, but it is one case where we can know.
Okay, sir.
So here you can see all the cases are assembled together. Here few things you can observe in this case. This is the first is the point is in first quadrant, where we have front view here above the reference line and top view below the reference line, and in second case where the front view and top view both are above the reference line where the point is the second quadrant, and in case of third quadrant the point projection of point which is top view, that is above the reference line, and the projection of point that is the front view is the below the reference line. So in these and again we can consider a fourth one also. In the fourth quadrant the projections are below the reference line. So in case of first and third, in case of first and third, you can see in case of first quadrant the front view is coming above the reference line, and in case of third quadrant the front view is coming below the reference line. Both are opposite. So you can make a note that, and in second and fourth case, both the projections are either above the reference line in case of, like in case of second quadrant, and are both the projections are below the reference line, that is in case of fourth quadrant. So only there are two cases where first and third we can get the distinct projections. So later on you will know that why we will have the only two types of projections, either first angle projection or third angle projection, not the second angle or fourth angle projections are there, because the points may overlap each other. In that case we will not be able to know the actual description of the object. So that's why two types of projections are not used. That is the second angle projection and the fourth angle projections, because both in both the cases point may overlap. So whatever feature we want to project, that may overlap, so we cannot get the clear picture. Only first angle projection and third angle projection are there. So this is all about today's lecture. So we can stop it here, and if you have any question, please ask.
Sir,
Hmm.
so what is the need of this projection? This stuff we just studied, what is the need of this?
This is the basics of the there are any more there are more projections like projection of points. These are basics of the orthographic projection which you have to study. Later on you will use these types, these projection of points and projection of lines in case of when you project a object that is three-dimensional object, where you will draw or show the projection of a edge of an object. So for an edge, you can show that you can understand that the edge is represented by a line. So for that you should know the projection of lines. So basics of the that we should know beforehand.
Okay, sir. Okay.
Okay, so now I am going to stop it here.
Can we leave, sir?